Okay, in your lab this week, you have to calculate the confidence interval for two sample estimates here. So we're going to talk about, let's do an example with you're going to do one for God and one for satisfaction in your lab. I'm going to do example for the variable spanking here that you've worked with that before. So again, we're all going to start with a pivot table. And let's say our research question here is, what percent of Americans, right, strongly agree with spanking to educate their children? All right, that's our research question. All right, so we have that variable spanking that asks exactly that question. So I'm going to select all and then data, pivot table in a new sheet. So create that. Okay, so we are in this, the data editor. This is the results part. So we're going to go to the rows, and I'm going to choose the variable spanking. And I'm going to go to the values and choose that variable spanking again. And I'm going to, okay, well, we have it. We have the absolute frequency here. Okay, but we have these values that we don't want. We want to filter those out. These are people who were not asked the question, and it's quite a few of them. And then the don't know people and doesn't apply, we're going to filter them out because they didn't really answer the question. So filter, add, go to the variable spanking again. It's showing all of them, but we want to check all these out. The NA, the don't know, or the IAP. Okay, now we have it. So the question that we want to answer is, what percent of Americans strongly agree with spanking? All right, good. So the sample size here is 1,529. So I'm just going to start writing these things here. So N equals 1,529. Okay, we're going to need that, right? We're going to need the proportion, and that's the percentage, right? Or the proportion of people who strongly agree. And we're going to need that Z value, right, for the formula. And that Z value comes from how accurate we want to be. I'm sorry, not how accurate, but how precise we want to be. We want to be 95% sure, we want to be 90% sure, or we want to be 99% sure. Okay, let's say we want to be 95% sure. Now, if you go back to your notes, you will remember that if we want to be 95% sure, this Z value needs to be 1.96. All right, good. Now, all we need is that sample proportion here. What percent of respondents in this sample strongly agreed with the statement? So how do we get that? Let's go get that as a percentage. We go to values. Right now it's just showing the number, but we want it as a percent of the column. So 22.24% of respondents in this particular sample strongly agree, right? So how do we put that as a proportion? Remember, a percentage is just a proportion that is multiplied by 100. So in this case, if we divide that by 100, we will get 0.22, right? That's the proportion of respondents and I'm just rounding it, right? I'm not putting that 22, 24. So we know that in this sample, 22% strongly agree. 22% strongly agree. This is the sample size, and that is the z-value for 95% confidence. Okay, now we just need to plug these numbers in the in the formula. And again, the formula was I'm going to share this again. Maybe we can even copy this here. I wonder if we can. Yes, okay, that was the formula. Good, I got it there. All right, P is 0.22. All right, so let's start with these parts here, okay? So we have everything we need. So let's start with this little here. This would be equal to, and you can do this in a calculator too. It would be equal to 0.22, that's that P, right? Times, open parentheses, 1 minus 0.22, right? And we're gonna need to divide all that by sample size, which is 1,529. Okay, it's a super small number, right? Again, this was the 0.22 P times 1 minus 0.22, and all that divided by n, right? It's this part inside of the square root. Now we're going to get the square root of that. And to do that, we just go equal SQRT, and that will take the square root of anything. And we want the square root of that number there. So the square root is a little bigger now, right? So now we have that part of the equation. Now we need to multiply it by z. And remember, this part of the equation, the z times the square root of all this, gives us the margin of error. So that's the margin of error here. All right. So we need to multiply 1.96 times this. So the margin of error is 0.02. Now to calculate the confidence interval, we just need to, and I'm going to take some numbers off this. This is really big. Okay. Okay, boom. That's our margin of error. That tells us how far away we are in this number, right? This is our sample, how far away we are, or we may be from the population true percentage, right? So the confidence interval, again, is equal to our population proportion plus this, right? That's gonna give us one of the values, and our population proportion minus this. So this is equal, so it will be equal to 0.22 minus 0.02. That's one of the values. That's 0.20. And the other one will be equal to 0.22 plus 0.02. And this is our confidence interval, right? How do we interpret that confidence interval? We can say we are 95% sure that in the population, right? And the population in this case is Americans, right? Between 20 and 24% strongly agree with spanking as a tool for educating children, right? We are 95% sure that in the population of Americans, between 20 and 24% of them strongly agree with spanking. We know that in the sample, it's 22% of them. In this particular sample, it's 22% of them. But now we can make a statement about all Americans because this is a random sample of Americans. And we can say that we are 95% sure that between 20 and 24% of them strongly agree with spanking. Okay?